Hello, I'm Hui Ling and I'm a PhD researcher at Imperial College London. My background is in aerospace, but I worked as a software engineer at THG for about 3 years. During that time, I worked on two UKRI digital security by design projects, which involved porting the OpenJDK's hotspot Java virtual machine and components of GraalVM, like the compiler, to run on ARM's Morello board, which provides memory safety guarantees. This was to create a secure polyglot JVM. In addition to my research, I was involved in conducting an internal training program for STEM graduates with little coding experience to become fully fledged software engineers. Now, I'm a PhD researcher in sustainable aviation, investigating the effects of climate change on aviation turbulence. This means that my research is at the intersection of computational air elasticity and atmospheric physics. The term software engineering was coined by Margaret Hamilton. She worked on the software for the Apollo program. And although the management of software as a discipline was born out of the aerospace industry, this has become a lost art within aerospace itself, and even more so in research. A symptom of the problem is Git, or more, the lack of Git. Coming back to academia, I was surprised to find that many in the aeronautics and physics departments do not use Git. Those who do simply use it as a backup system and are not aware of its full potential. The lack of Git is just an example of the basic software skills that are missing but are vital to conduct research effectively and ensure its reproducibility. At the root of the problem is the fact that researchers are overstretched and pulled in 1,000,001 different directions. There isn't the time and capacity to learn something new when their existing system works. Moreover, there is the preconceived notion that these mystical software practices are difficult and time-consuming to learn and maintain. As a result, there is a culture whereby basic tools and skills that are fundamental to research reproducibility are optional extras. I want to use this fellowship to change that. To do it, I need to reach out to the disengaged population, to those who would not attend workshops or carpentry sessions to learn about software practices. My plan revolves around giving 15-minute talks. 15 minutes is the sweet spot for having enough time to introduce a topic and is short enough to keep their attention. These talks will most importantly demonstrate the ease of use to debunk the myth. It will also highlight how tools like Git can promote research reproducibility. For example, with code in a remote public repo, others will be able to run it. By explicitly linking how a given tool improves productivity, eases pain points, and the long-term benefits, it would promote adoption as it improves their quality of life. For example, having an SSH config and using rsync makes working on a remote machine a lot easier. I know of people who would push and pull from a Git repo to get their changes onto a remote machine. There is also a need to inculcate a mindset of using existing solutions instead of building a custom one. For example, using NumPy for differentiation instead of doing it manually with for loops. The goal of these talks are to most importantly share the received wisdom that is gained from working as a software engineer and having someone more senior show you the ropes and the pitfalls. For example, there are a lot of websites about the various Git commands and how to use those commands, but I have not found any that tell you what should or should not be in source control, like secrets, or how to make effective Git commits with a good message and the relevant changes such that the Git history is useful. This sounds like common sense, but that's only for the initiated. It's like how it took my friend 25 years to learn that bananas shouldn't be spicy. Given the time constraint, another goal would then be to equip the attendees with the vocabulary to Google, as without it, it's a challenge to find the right information. I would then signpost them to good resources that provide more information about how to use a tool, as there are a wealth of tutorials online and there is no need to reinvent the wheel. Lastly, I would emphasize the practicality of the tool. These talks would take place in three forms. Firstly, guerrilla talks, which would involve popping up in an open plan office or where people have lunch to give the talk. Secondly, it would take place during inductions as new PhD students tend to arrive in a batch. This would need working with the departments, and I'm hoping that the fellowship will provide me with the footing to do so. Lastly, it would be by having regular sessions with snacks and coffee. These sessions are more likely to attract people who are interested in software or people who are willing to gamble 15 minutes and want free food. But I'm hoping that this would create a community of people who enjoy learning and sharing about tools and workflows that they have found effective. As repetition is key to getting a message across, my plan is to find others who are equally passionate about improving the quality of research software and training them to carry out these talks. The funds would be used to help support these efforts. Hopefully, this would help to make this effort sustainable, expand to the entire college, and last beyond the tenure of this fellowship. I believe that this fellowship would not only provide me with the means to carry out, but also the credibility to convince others that learning how to use tools which are fundamental to software engineering is worth it. Moreover, it would be great to learn from other fellows how my plan could be improved, because I have a dream that one day all researchers in the aeronautics and physics department would have basic software engineering skills, or at the very least, use Git. Thank you.